Some programming stacks make AI look brilliant. Some make it look drunk. That sounds like an exaggeration until you watch the same coding agent work in two different projects. In one repo, it reads the code, edits 3 files, runs the test, fixes the failure, and lands a change that actually makes sense. In another repo, it opens 12 files, invents a pattern nobody uses, adds a package for no reason, breaks the build, and then apologizes in perfect English. Same model, different stack. That is the part developers are underestimating. AI coding is not only about the model, it is about the shape of the software you ask the model to modify. Agents are better when the stack has fewer hidden layers. They are better when errors appear early. They are better when the type system argues back. They are better when the build is boring. They are better when the runtime has obvious rules. They are worse when everything is implicit, magical, heavily configured, and split across 5 tools that all pretend to own the same behavior. So this is not a list of the trendiest stacks. This is a list of stacks that make AI write better code. Not because the AI likes them, because they give the agent fewer places to lie. Hey, don't forget to like and subscribe for more like this. Now back to the video. Number 10 is Go with SQLite. This is one of the most AI-friendly combinations around. Go is boring in exactly the right way. The compiler is fast, the formatting is standard, the dependency model is understandable, the language has fewer ways to express the same idea that matters for agents. An AI can write clever code in almost any language, but clever code is not what you want from an agent. You want code that fits the repo, compiles quickly, and fails loudly when it is wrong. Go gives you that. Then SQLite removes a whole category of moving parts, no local Postgres setup, no container waiting to boot, no connection string ceremony for simple apps, no background database service that the agent forgot to start. One file, one schema, one clear set of queries for small tools, dashboards, internal apps, prototypes, and agent-written utilities. That simplicity is powerful. The agent can create a table, write a query, run the app, and inspect the result without negotiating a small infrastructure treaty. The trade-off is scale and concurrency. SQLite is not the answer to every production system, but for AI-written software, especially small useful tools, Go plus SQLite creates a narrow path, and narrow paths are where coding agents behave. Number 9 is HTMX with server-rendered HTML. This one sounds almost anti-modern. That is the point. The typical front-end stack asks an agent to juggle routing, state, API calls, client caches, hydration, loading boundaries, styling, component libraries, and build tools. That is a lot of surface area for one button that opens a modal. HTMX changes the shape. The server returns HTML. The browser swaps pieces of the page. A lot of interaction becomes attributes and endpoints instead of a client state machine. For AI coding, this can be a gift. The agent has fewer files to coordinate. The source of truth is closer to the rendered output. The backend and the UI speak in a simpler contract. If a form submits to an endpoint and returns a partial, the path is easy to follow. This does not mean every app should use HTMX. If you're building Figma, use a serious client app architecture. But if you're building admin panels, dashboards, CRUD tools, internal systems, queues, billing screens, moderation tools, and basic SaaS services, HTMX can remove a mountain of accidental complexity. And accidental complexity is where agents burn time. The lesson is bigger than HTMX. AI writes better code when the framework has fewer invisible moves. The less magic in the client, the less magic the agent has to guess. Number 8 is TypeScript with strict mode and a small framework surface. TypeScript can be amazing for AI. It can also become a theme park of generic types that nobody understands. The difference is discipline. Strict TypeScript helps agents because it catches shape mistakes early. If a property is missing, the type checker says so. If a function returns the wrong thing, the type checker says so. If the agent passes a nullable value into a place that expects a real object, the type checker says so. That feedback is gold, but the stack has to stay readable. Agents do not do well when every type is a puzzle box. If your code has nested conditional types, global module augmentation, enormous inferred objects, and framework magic that changes behavior at build time, the model has to reason through a maze. A better TypeScript stack is strict, explicit, and boring. Clear interfaces, small modules, schema validation at boundaries, readable API clients, tests around business logic, a build command that fails fast. The framework can be React, Next, Svelte, Astro Remix, or something else. The important thing is not the logo. The important thing is that the repo makes illegal states hard to write. When TypeScript is used that way, it becomes a second reviewer that never gets tired. Number 7 is Rust for core logic and command line tools. Rust is not always the fastest way for an agent to produce code, but it is one of the best ways to make bad code obvious. The compiler is strict, the ownership model is explicit, errors are loud, unsafe behavior has to be named. That makes Rust a strong choice for places where correctness matters more than quick improvisation. Parsers. Command line tools, data transforms, build tools, file processing, infrastructure, utilities, small services with serious correctness needs. AI agents often struggle with Rust at first because the compiler refuses to accept hand waving. That is annoying, It is also useful. The agent edits, the compiler rejects, the agent reads the error, the agent edits again. That loop can produce surprisingly solid results because the language forces the conversation to be precise. The catch is that Rust can become too much for simple product code. If every tiny feature requires navigating lifetimes, traits, async runtimes, and complex generics, you may spend the agent budget fighting the language. So the sweet spot is not necessarily all Rust everywhere. It is Rust where the guardrails are worth the friction. For AI written tools that touch files, parse formats, or run in automation, that trade can be excellent. Number 6 is Python with types, tests, and boring packaging. Python is easy for AI to write. That is both the strength and the danger. The model has seen mountains of Python. It can produce working scripts very quickly. It can glue APIs together. It can process data. It can build small automations. It can create useful tools in minutes. But raw Python lets too much nonsense survive until runtime. That is why the AI-friendly Python stack is not just Python. It is Python with guardrails, type hints, a real formatter, a fast linter, small tests, clear dependency management, simple entry points, schema validation at inputs and outputs. When those pieces are present, Python becomes one of the most productive AI coding environments. The agent can move fast, but the tools still push back. When those pieces are missing, Python becomes a pile of plausible scripts. Plausible is dangerous, especially with AI. The best Python repos for agents have a tiny, boring path from idea to verification. Install, run, test, type check if the project uses it. No mystery notebooks as production. No hidden global state. No import path rituals. No dependency soup. Python plus discipline is excellent for AI. Python without discipline is where demos go to become maintenance problems. Number 5 is Astro for content-heavy sites and simple product pages. AI agents are often asked to build websites. Many of those websites do not need a full client app. They need content, layout, components, images, metadata, and a small amount of interactivity. Astro is strong here because the default model is simple: ship less JavaScript, render content clearly, use islands only where interaction is actually needed. That is a good mental model for agents. The agent can create a page without inventing a state management system. It can update content without touching a client router. It can isolate interactive widgets instead of turning the whole site into one moving machine. For marketing pages, docs, blogs, portfolios, landing pages, and product explainers, this reduces the number of ways the agent can overbuild. And overbuilding is one of the most common AI coding failures. Ask an agent for a simple page, and it may create a dashboard framework. Ask for a form, and it may add 3 libraries. Ask for a content site, and it may ship a client app. Astro gives the repo a bias toward restraint. That bias helps. The agent still needs design judgment, but the stack is saying, only add client complexity when you can justify it. That is exactly the kind of default AI needs. Number 4 is Django or Rails for conventional web apps. This may annoy people who love inventing architectures, but conventions are excellent for coding agents. Django and Rails are old enough, documented enough, and opinionated enough that the agent usually knows where things belong. Models go here, controllers or views go here, templates go here, migrations go here, tests go here. Routes are defined in a known place, auth has known patterns, database access is not reinvented in every folder. That consistency matters more than novelty. AI agents are pattern machines. Framework conventions give them patterns that have names. The downside is framework magic. Django and Rails both have implicit behavior that can confuse an agent, but that magic is at least common magic. The model has seen it, the docs are deep, the errors are searchable, the folder structure means something. Compare that with a custom architecture where every team invented its own service layer, naming scheme, and validation strategy. Humans may understand it after a month. The agent gets one prompt. For normal database-backed web apps, conventional frameworks are still underrated in the AI era. The boring path is a feature. Number 3 is one binary backends. This is less about one language and more about one deployment shape. A backend that builds into one clear artifact is easier for agents to understand. Go does this well, Rust does this well. Some Java and .NET setups do this well. Even Node can be packaged carefully. The point is that the runtime story is obvious. Build this, run this, deploy this. When a repo has 5 services, 3 workers, 2 generated clients, a shared package, a build cache, a container composition, and a deployment script that only works on one laptop. Agents struggle. So do humans. But humans learn the pain. Agents rediscover it every session. One binary thinking creates clarity, configuration is explicit, startup is easy to test, logs come from one process. The agent can reproduce failures locally. Again, this does not mean every system should be one binary forever. Real products grow. Some need separate services, some need queues, some need independent scaling. But many projects split too early. AI makes that more expensive because every boundary becomes another thing the agent must understand. Before you add another service, ask a brutal question. Is this separation helping the software or just giving the AI one more place to get lost? Number 2 is schema first API. Agents are much better when boundaries are written down in machine-readable form. Open API, GraphQL schemas, protocol buffers, database schemas, validation schemas, typed event contracts. These are all ways for the code base to say exactly what crosses a boundary. Without schemas, the agent infers contracts from usage. That can work until two call sites disagree. Then the model guesses which one is real. With schemas, the agent has something stronger than vibes. If it needs to call an endpoint, the shape is defined. If it needs to add a field, the contract changes in a visible place. If it needs to validate input, the rule can be shared by code and tests. Schema first does not mean bureaucratic. It means the boundary is not a rumor. This is especially important as agents start connecting systems. Your app talks to billing, billing talks to email, email talks to analytics, analytics talks to a dashboard. Every fuzzy boundary becomes a place where the agent can make up a field name and move on. A schema says no. That no is valuable. The future of AI-friendly programming is not just better generation, it is more executable truth. Schemas are executable truth. Number one is boring architecture with fast feedback. This is the stack behind all the other stacks. The best AI coding stack is not the one with the most impressive diagram. It is the one where a change can be made, checked, and corrected quickly. Fast test feedback, fast type feedback, fast local startup, fast formatting, fast build errors, fast rollback. That is why the old arguments about frameworks are changing. The question is no longer only what lets humans write code fastest. The question is what lets agents make a wrong move and recover fastest. Because agents will make wrong moves, the stack should catch them. The more delayed the feedback, the more expensive the mistake. If the agent needs 12 minutes to discover the app does not compile, it will make huge changes before it learns anything. If the agent gets an error in 3 seconds, it can correct course. This is why boring stacks are suddenly exciting. They shorten the loop, they remove hidden state, they make errors local, they reduce dependency drama, they give the agent less room to improvise. That is what makes AI write better code, not a magical framework, a stack that turns guessing into feedback. So the best stack for AI coding is not one stack, it is a set of properties. Obvious commands, clear boundaries, types where they matter, small files, common conventions, simple deployment, schema-based contracts, fast feedback, less magic, less ceremony, less invisible behavior. Go plus SQLite has those properties. HTMX can have those properties. Strict TypeScript can have those properties. Rust can have those properties. Python can have those properties if you add discipline. Django and Rails have many of those properties because convention does real work. The point is not to chase whatever stack is fashionable this month. The point is to build software that an agent can understand, change, test, and recover inside. Because AI coding does not reward the cleverest architecture. It rewards architecture with receipts. If the stack improves the agent wrong quickly, the agent gets better. If the stack lets the agent stay wrong quietly, you get slop at scale. That is the trade. And in the AI era, boring might be the most underrated performance feature you have.